Hello dear Optalix friends. Today we show you how with Optalix we can build a Gullstrand Eye. To do that we need Optalix, the program, and we have to think about how an eye according to Gullstrand would look like. Therefore we can take the formulaic handbook from the Swiss Optician Association. On page 122, we can see the theoretic eye according to Gullstrand. The numbers you will find on the page 123. We have all the indexes, the thicknesses, and the curvatures. These we will type into Optalix. To type something into Optalix, we have to deactivate the PIM. Standard-wise, there we have an object, we have an aperture, and an image, or an image surface. Now to build an eye, we need to add more surfaces. We can do that down here. So now let's start with the object first. The object is in an infinite distance, as it's already typed in. The object is surrounded by air. Therefore, we don't need any index here. Now the height of the object, we take 20 millimeters. As we have to take half of the diameter, we have to type in 10. So that we always know which surface it is, we can type into these commentary field object, or as we did, Objekt in German. So next we have to add a new surface. We do that so. This now is the cornea's front surface. According to our formulaic handbook, we have a radius of 7.7 millimeters. Now the thickness of the cornea is 0.5 millimeters. The index of the cornea is 1.376, so therefore we type 376500. Since the cornea has a diameter of 12 millimeters roundabout, we type in here the radius, or the half diameter, of 6 millimeters. Here in the commentary field, we will type cornea's front surface, or as we did again in German, because we did that video the same in German before, Hornhautvorderfläche. Now for the cornea's back surface, we have to add a new surface, like so. Now here again, in our formulaic handbook, we can read that the cornea's back surface radius is 6.8 millimeters. Now the front chamber's depth is 3.1 millimeters. Now the index of the aqueous humor is 1.336. Therefore, we type in 366,500. Again, here the diameter is 12 millimeters. Therefore, we still type in the 6 millimeters we typed in before. Now in the commentary field, we will type in cornea's back surface, or here Hornhautrückfläche. Now the next step is the iris. The iris doesn't have a curvature, therefore we leave the radius on 0. Now the pupil diameter usually has an opening from 1.5 up to 8 millimeters, according to Miss Muller's book or script we had in school. Therefore, we will take a diameter of 2.375 as the half diameter. And here in the comment section, we will type in irisblende, which is the iris. Now, since the iris is directly laying on the crystalline lens, we don't have a thickness to put in. Next, we put in a new surface for the lens front surface. Now, the curvature for the lens front surface is 10 millimeters. The distance from the lens front surface to the surface of the lens nucleus, we will type in 0.546 millimeters. The index of the crystalline lens is 386,500. Now in the commentary field, we will put in Linsenvorderfläche, which is the front surface of the crystalline lens. Now next, we have to type in the lens nucleus front surface. The radius is 7.911 millimeters. Now the thickness of the nucleus is 2.419 millimeters. And the index is 1.406. That's why we type in 406 and then 500 again. Now in the commentary field, we will put in the lens nucleus front surface, or the Linsenkernvorderfläche in our case. Now next we have to put in a new surface, which is for the lens nucleus back surface. Now from our handbook, we find the curvature, which is minus 5.76, as I already typed in. Next we have the distance, which is 0.63 millimeters. And then we have the index, which is 1.385. Therefore, we type in 386,500. The commentary field, we will type in lens nucleus back surface. Like so. Now next we have the lens back surface. The radius of the lens back surface is minus 6.0. And we have the index, which is 1.336. Therefore, we put in 366,500. And again, put in a comment, which would be Linsenrückfläche, which stands for lens back surface. Now, the image surface here would be the retina. The distance from the cornea to the retina we can find on our formularic handbook on page 126. Here you see it. It's 24 millimeters. Now from these 24 millimeters, we have to subtract all the distances that we have already used. And then get to 16.8 millimeters, which we type in right here. Now, since the eye is pretty round, I would say we take the radius of the retina minus 12.0 millimeters. Put it in right here. Perfect. Now, the height of the retina will just take 12 millimeters. Now, if we now generate the image, it looks a little strange yet. So that's why we have to optimize the height of these surfaces. So for the lens, for the cornea's front surface, we will put in 4.8 millimeters. Now for the lens nucleus, we will put in 3.8 millimeters. Now for the lens nucleus back surface, we will also type in 3.8 millimeters. And for the lens back surface, we will type in 4.8 millimeters. So here we have the image, which looks much better. Now we enable the edge plotting and we put in the commentaries. And yeah, that's our eye according to Gullstrand. So now these were our sources, which is the formularic handbook from the Swiss Optician Association and the script from Andrea Müller-Treiber, which we had in school. I hope you liked this video and please leave us a thumb up and a comment. Thank you very much and see you next time.